After we finish 10.4 today, after we go through this example, go through any questions that you guys might have found if you started homework, when you started homework last we are going to go to section 12.3. It's going to be section 12.3 in our notes because it is section 12.3 in another book. So I actually have this section from the other book scanned in so that you guys can look through the section, look through examples, etc., etc., etc. I do have the section, random blank page, scanned in if you, oh, that's interesting, if you want to see it. However, I also have homework problems from the other book because it's not going to be in our book. It's not our 12.3. It's another book's 12.3. We're taking notes in our chapter 10 because it has to do with our chapter 10. It didn't have to do with its chapter 10 in this book. It was chapter 12 in this book, which is why it's so weird. And I have the certain homework problems that are due that are reflected on your homework sheet on here. And if you guys look, oops, not there. But did you see a second ago? What happened after that blank page down here? Answers for odds. Oh. So I stole the answers from the odds that you guys could check. And if you notice, I think I mostly assigned odds. There might have been like one even. But do you guys notice how the conics are rotated here? Are they rotated two-dimensionally or three-dimensionally? Yep. They're being spun. So they're not just being rotated. Yeah, it's cool and all. They're being spun. And as they're spun, these three-dimensional figures appear. Now, some of you are like, I am not that artistic. Well, okay, we'll learn how to be that artistic, at least roughly. But this is where we're going in section 12.3. We are taking conic sections, two-dimensional conic sections, and we are rotating them. And when you it generates a three-dimensional quadric surface. Anyway, so that's where we are going. That's why there's the weird 12.3 in your homework page. That's why there's the weird 12.3 on the board. That's why if you go to look at our 12.3, it has nothing to do with what we're going to be covering in our notes. Does that make sense? Okay, cool. But for right now, let's finish hyperbolas, yeah? Sound good? Okay, hyperbolas. What? Anyway, I was going to try to copy that, and it was not going to work out. Did we finish? We did, didn't we? This example from yesterday? Yeah. We were starting to talk about asymptotes. We might not have gotten the full idea about asymptotes, but at least we got the formula written down. Let's go ahead and come over, work on this problem. We'll get to practice the asymptotes because that's part of the problem. Ending with a sketch. And if you can, understand this problem, well, I think we'll be doing all right. Actually, we might need to do one more after this. Did anybody figure out this is a weird one? Where'd the one go? Did anybody figure out the one disappeared? The one disappeared. Okay, hold on. Some of you didn't even get to the one disappearing. You're like, what one? Well, there's only one important one. That's okay, we'll see. 16, y squared. If you didn't see the one disappear, you got lost somewhere along the way. I'm grouping the y's, I'm grouping the x's. Can anybody tell why I'm putting the y's first and the x's second? Ellipses, I always did it the other way. Because what? I saw my minus. And for hyperbolas, there's a minus in the middle, and I have a positive one before and a negative one after. Joel, this is a hard one, an important one, bud. Here we go. Hand down. Too much temptation. Everybody else currently doing okay. All right, so I can tell. Nicely done. Look at him just. Here we go. I have the y's, I have the x's. I put the x terms second because that was the negative one. In hyperbolas, I have the minus in the middle. Okay, complete the square. What do I do here with the y's? Factor out the 16. What's left inside? Why am I leaving it blank? How am I going to complete the square? Okay, pause. They were excited. Are we okay? Middle term. Cut in half, square it, throw it in. Now, we're going to keep going, but over here, can't I already put negative 63 plus, why am I doing 16 times the blank of 4? The 4 is times the 16 on the outside. 4 and 16 is 64, PS. Okay. Well, if hyperbolas have a minus outside the parenthesis, if I have to take it away from 1, what am I going to have to take it away from? also the other. Yeah. I have to take away from one and the other because I need to put the parenthesis to group my x terms, right? Does that make sense? Okay, now why is there a blank? I'm going to complete the square. And? So what do I have? And why am I going to put a negative 1? Does that make sense? Okay. The whole point of that was to try to simplify it to make it more like the yellow box in section 10.4, formula for hyperbolas. Jacob. Because when I'm grouping my x terms and I'm pulling the minus away, I have to factor it out of both. Because I need it to maintain its original meaning of a minus and a plus. So I factored out a negative 1. So when I need to get a leading coefficient of 1, I mean literally 1 as in positive 1. Does that kind of make sense? Okay. So the whole point of this was to be able to factor into perfect squares. So this guy's a perfect square. He's y plus what squared? 2. Good. 2 squared. 2 squared is 4. 2 plus 2 is 4. Or I should say 2y plus 2y is 4y. This guy is going to end up being x minus, right, 1 squared. 1 times 1. Negative 1 plus negative 1, x. Okay. Oh, 0. Where did my 1 go? Because I'm supposed to have an x minus h squared over, hopefully something squared, minus y minus, wrong form. Y minus k squared over something squared, minus x minus h squared over something squared equals 1. Oh, divide by 0. That makes everything better. No.
Undefined.
The hyperbola is undefined. The problem is, that doesn't mean the whole thing is undefined. It's a degenerate. Remember section 10.2, hyperbolas, ellipses, parabolas? Then the degenerates. Lines, points, intersecting lines. What? How is this a degenerate? Well, the 1 went away. I have a 0. It is a degenerate. Man, these degenerates. Anyway, so let's not use that. Anyway, coming back. Is this a hyperbola? And the answer is no. But it looked so good. It did. It looked like a hyperbola. I would have guessed hyperbola at the very beginning, but I would have been wrong. Ooh. Multiple choice problem on the possible test to come next week. Maybe look at it quick and say hyperbola, but then maybe double check. Ooh. Coming back. Coming back. So what is this? Well, I mean, it's a 0, so zeros are, okay. If I move that to the other side, it's kind of nice. I can add the x stuff to the other side. Well, it's not a hyperbola, so I can't use the hyperbola clues. So I'm just going to use algebra that says, I don't know, get y by itself. I'm used to function mode. Oh, I can square root the entire thing, plus or minus square root the entire thing, in fact. So then, actually, I would end up with absolute values all over the place. Wait, hold on, not yet. Square root of 16 is 4. Square root of y plus 2 squared is y plus 2. Oh, this is getting nicer. Square root of a squared is x minus 1. Now, I just kept in all the absolute values because they both have the plus or minus thing, so now it gets a little confusing. Long story short, we can just say 4 times y plus 2. Take out the absolute values, put a plus or minus. I can divide by 4. A square root of a squared is always absolute value. That's technically the definition. Some teacher somewhere probably lets you shortcut it and just start writing plus or minus to shortcut the process of how to solve an absolute value equation. It's a little dangerous, but usually okay. Yeah. Y is equal to plus or minus 1/4 x minus 1 minus 2. This looks an awful lot like a line. 2 lines. Yes. 2 intersecting lines. Now, to find it, we'd have to work a little bit. We have to distribute this little positive 1/4, negative 1/4, put it all together. Long story short, someone can double check my mental math. I think we get a positive 1/4 x. If that's positive, negative 1/4 minus 8/4 would be minus 9/4. Or if we had used the negative 1/4 instead, negative times a negative would be a positive 1/4 minus 8/4 would be minus 7/4. This is something. It's just not a hyperbola. It's just two lines. Well, if you were artistic, you might want to go back and look at your pictures at the very beginning of 10.2. If you weren't artistic, maybe you want to look at my pictures at the beginning of 10.2. Just a thought. So my pictures at the beginning of 10.2. How do you get hyperbolas? You slice straight down through the top cone and the bottom cone, right? You slice straight down to the top cone and the bottom cone. You get hyperbolas every way you slice except right in the middle. So what is it? Looked like a hyperbola because it was doing what a hyperbola does, but it sliced right in the middle. It's just two lines. Look at that degenerate. All right, anyway. I do not think it means what you think it means. Anyway. Here we go. So, this was good and all because it showed us something tricky that could happen, the degenerates. It did have us practicing, get the y's, get the x's, the minus goes in the middle, factor it out, complete the square. It had us practice a lot, but it didn't have us practice the asymptotes, and that's what I was trying to practice. So, somebody from homework, was there any problem that had you take an equation, whether it was nasty like this one, not the exact, don't give me a degenerate please, but something nasty like this one, or maybe a nice pretty clue one where you had to get the sketch. That's the type of problem I want. Why not? Let's do a homework problem to help all of our poor little stressed out people that for one reason or another have gotten behind. And they can do a homework problem now and have it ready for later. People who did homework, find me a problem. Go. Something where you're supposed to get a sketch. 31? Oh, that works, right? And it wasn't degenerate? Anybody's done it yet? Uh-oh. It wasn't degenerate? Hey, how can we tell if it's degenerate? Is there a cool app in our calculator? Okay, pause. Let's see if the cool app in our calculator might help us figure out whether or not this guy is degenerate. Because I just mentioned you might want to check people on a test next week. So, hold on. Where's your cool app? You don't have it either? Oh, that's not going to work. Yeah, sorry. I mean, people that don't have the app, really the only thing you're missing out on is just memorize your standard forms, which you should have memorized anyway. So, I don't know. Anyway, yes. Well, we were trying to, but it was a degenerate, so it's not a hyperbola, so we didn't have foci and vertices and, you know what I mean? So since it was a degenerate, we were like, hey, 2 lines, yay, we're done. That's why I'm trying to get one now where we're going to find everything. And it's an actual hyperbola. Not just a hidden one. Guys, apps, right? Conics, was it number 8? We think, hold on, number 31, we think it's a hyperbola because there's a minus, right? Can we put in a oh, guys, look. Can we put in a hyperbola in a nasty form? No. So don't we have to know how to complete the square? Yes. Ah. All right. So let's go ahead and let's grab number 31. Now it's mad at me. That's okay. That's fine. I can deal. Story of my life every day whenever I start teaching and you guys don't want to do math. Okay, so. I know, right? Isn't it sad? I thought so too. Understandable. Understandable, but still kind of sad. All right, I need someone to keep me honest as far as the directions once I get a picture of it. But I think pretty much all we're trying to do is all the characteristics. Now, Chris, double check. This is a homework problem, right? Cool, so we can be helping people. Guys, right now, wherever you are in this class, open up your workspace, get out a blank piece of paper. Let's do this problem together. It's a homework problem, okay? And it's a hard one. Yeah. Yeah, I guess so. I like the workspace because then you're already in your homework spiral. You have it because you're doing homework. You flip back, you get it. But it's up to you. It's up to you. I don't care. You should have your notes anyway. Some people aren't caught up in their notes, so even they can go to their workspace. It's just an idea. It's a place anyone can go if they need to. All right, here we go. Why am I grouping my x terms and my y terms this way? Why is the x first this time? The negative needs to go in the... Sure. I was thinking the middle, but okay. Later. There you go. It just needs to go later. I don't know. Cheaters? I mean, just kidding. I'm just kidding. All right, anyway. Later's not always right, but it can be. It can. Not often. Slater's like a whole homework platform thing where Bob asks questions. Chegg's like the college version. Anyway. P.S. When you go to college, rent textbooks. They're cheaper unless you want to keep them. Exactly. So rent them, and then you don't have to pay as much. Or just spend all the monies that nobody has. All right, so here we go. I don't need to factor anything out of this guy because he only has a 1 anyway, right? Yeah. So let's complete his square. Take the middle, cut it in half, and then? Are we okay? Okay, extra conversations, even though they might be helpful for you, they're distracting for others, so shush. Okay, I can put in the 1, and there's nothing in front of that 1, right? So it's just 1. What am I going to factor out? Negative 9, true. I get y squared
minus 6.
Plus 6. Why? Careful. Take the 6, cut it in, and square it. Now I can put the 9. What am I going to put over here? 9. 9 times 9. Don't know what accent that was. Okay, so. Exactly. Good catch. I wrote the 9 times 9, but we did need the negative. Kiddos. Subtract, add, combine. Minus 80. You found me another degenerate. Now we have to do 2 homework problems.
That's not a big problem.
Find me another one. Because this 9, I added in. That's the blank. But looking in front, it's really being multiplied by negative 9. So to make it balanced, I need to make sure it's the same. All right, what's another one? Maybe a clue one. Maybe not one of the nasty complete the square ones. Maybe I wasn't that mean.
32.
32. Well, is that a homework problem though?
That's also degenerate, by the way.
Oh, you already tried it?
No, 32 is.
Oh. Oh, that, yeah, we did already do it in class. Okay, read me homework problems. Give me one of these ones. 26. Perfect, and it's an even. Here we go. Perfect. Oh, we're doing Brave now. Oh, no. We're doing Shrek? All right. Here we go. It's not degenerate because there's a 1. The degenerates show up on the nasty long ones because you like move everything and then it's a 0. But good accent. Nasty? I don't know if nasty can be Irish. All right. Now that we're awake, let's do a problem. Now we know what to do, though. Just bust out accents. Okay. Shh. Now it's How to Train Your Dragon. Is that what we're doing? Okay, kiddos. Thank you. Who's A? It's already all nice and pretty. A is 12. Who's B? Who's my HK? Which direction is my hyperbola? Why? Why does it have to be this way?
Because it's A.
So, to sketch, couldn't we do our 1, 2, 3, 1, 2 here, right? Maybe we don't even need to stress about figuring out exactly what it looks like first. Maybe we can just look at the equation. And maybe we can look at the equation and say, what's underneath the x1?
144. A.
look at the first, it's x, and I'm going to be moving up. What direction to get to the vertex? Left and right. So I'm going to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in order to get to one vertex. It's a little rough. So maybe I should change my units. Anybody feel me on this? I'm starting to run out of space. Let's change my units. Let's go by threes. Anybody okay with that?
I like that.
All right. So negative 3, 2. We'll still go by twos here. Then we'll go, I have to go 12, right? So I'm going to go 3, 6, 9, 12. There we go. That'd be 12, right? And then I'm going to go 1, 2, 3, 4. So that'd be negative 15. You guys cool with that? Because I need to go negative 6, negative 9, negative 12. I need to go 12 more. So exactly. Let's show that, though, because that's kind of easier. Remember, maybe it's easier than the picture, because if we start at negative 3, 2, we need to add 12 to the x. So what's negative 3 plus 12? 9. And what's negative 3 minus 12? And why are we doing 12 with the x? Exactly. Exactly. So far, we have our center, right?
Yes.
If I can spell. We have our vertices,
Yes.
which are going to be negative 3 plus or minus 12, which we did do, but just to show you why. Plus or minus 12, 2, which ended up being negative 15, 2, and 9, 2. Okay, so we have our vertices, we have our center. Someone with directions, what else do we need? I'm guessing foci? Okay, asymptotes, and then. So foci, we need C. We need to see what the foci is. R, plural. What's the formula for foci? Where are the foci? Are they in or are they out? Yeah, they're out, right? I have hyperbolas. So if they're out, aren't I going to use the c squared equals?
A minor plus B.
I need it out. I need to add. I need to make it farther away than A. So therefore, I can go ahead and plug in my 144 plus 25, which is 160. That's the perfect square of? That just changed. Okay, so now I have negative 3 plus or minus adding to the x, because that's who was my initial term, my orientation, 13. So can't I get negative 16, 2, and what do you guys got, 10? 2?
Yes.
So it'll just be like, oh, that's like one more. That's not even a full tick mark. Well, okay, I'll just. Okay. AJ, oh, asymptote, right? Eccentricity. The ovalness is only for ellipses. But good job remembering C over A. That's okay. Here we go. Asymptotes. Guys, I need everybody focused in. I know. But we have not really covered asymptotes yet. So, look in your notes. No, flip back in your notes. We wrote down yesterday for the asymptotes right underneath all the yellow box stuff. Asymptotes, they always start from the center, like everything else. Vertices start from the center. Foci start from the center. Asymptotes start from the center. Okay, so we're starting from the center. But to make a line, don't we need a rise over a run as soon as we have a point? Don't we have an A and a B that goes with an X and a Y measurement? So can't we maybe go, ready? You can look at your formulas, plus or minus B over A or A over B, depending on which one we have, but just think about it. Couldn't I rise 5? And couldn't I run 12? And couldn't I make a line? M is equal to plus or minus B over A over B, I don't know, the Y1 over the X1. The Y measurement over the X measurement. So 5 over 12. Now, sadly, my y units are 1s and my x units are 3s, so they're obviously not equally spaced. But the idea still remains. I go up 5, I go over 12. But wait a minute, that's only one asymptote. I'm supposed to have, because I need both of them to hold in my branches and to see exactly how concave it's supposed to be. How do I do the other one? Minus. So instead of going up and to the right, I'm going to go up and to the left. Booyah. Now, how do I finish my hyperbola? I start at my vertex and I say, how curved are you? Oh, just go to the asymptote. How curved are you? Go to the asymptote. How curved? Go to the asymptote. How curved? Go to the asymptote. Dun, 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 dun. How do we do the asymptotes? Start from the hold on. Start from the center. Always from the center. Move out, vertex, out, foci, up and over to the asymptotes. It's okay. It's okay. Start from the center, Joel. Always y over x. So the trouble is, that's why in your notes I put b over a sometimes and a over b sometimes, because if these switch, then the letters switch. Does that make sense? Cool. All right, so then my asymptotes. Oh, sorry, Val. Thanks. Got it. Okay. Does that make sense?
Yes.
All right. I think this is probably the hardest homework gets. We talked about the degenerates. We did that homework problem. Basically, you just need to keep on solving like we did in class. We talked about one of these ones where you had to take the equation and you had to actually get the graph. What didn't we talk about? The ones where you have clues getting equations. But guys, didn't we do that yesterday?
Yes, we did.
I think we had clues getting equations. I think we had clues getting equations. All right. Let's go on to, do you want to write down homework real quick if you haven't yet? Take a picture of it so you have it. But otherwise, we're moving on to 12.3 to see how do we spin these conics. How do we spin a snappy snap?
Can you explain our process again? So we're going 10.4, 12.3.
Yeah.
Is this the hour?
No. That's why it's in your class folder underneath handouts. Yeah. Yeah, but if I were you, I would call it 12.3 like OT, other book, or just say other book. That's what I'm going to be saying, other book. Because if someone goes looking in our book, 12.3, it'd be bad.
So would you want us to print out these handouts?
You don't have to print them out. If you're cool, like downloading it, like PDF, like opening it on your phone and just using it. My people don't have much data. Just do it on Wi-Fi and then like save it to iBooks. You got it. Otherwise, if you want to print it out, totally fine. I don't mind. But it's in your class folder, which you guys access for homework problems anyway. But pause real quick. Where is it in your class folder? Yeah. Instead of going to the class notes or homeworks, handouts. I could have handed it out, but I'm saving trees. So there you go. There's the homework. Wait, where are the odds if you wanted to check the odds? No? Careful. Go to the other one because I want you to think of the section and know that the section is there if you want to look at it. Go to the end of this section. Does that make sense? Yes. Okay, cool. Plus, some of you, if you had the homework one open and it was really easy to get to the odd answers, it might be a little bit of a temptation. Okay, so that's the homework handout, and that's just the handout from the section of the book. Whatever you want to access, you can. But no stress, we're going to cover it ourselves. So sorry, last seconds, if someone is writing down or if someone wants to grab a picture. This is due on? Okay, Monday. Here we go. Kiddos, remember chapter 9? Remember how we split it up into 2 parts?
Yes.
Why did I split it up in 2 parts? Just so you guys knowing what was there and what it was all about?
Because the last 2 parts were totally different.
Yeah. I mean, there were NCRs in the last 2 parts, right? But it was probability, which was very different from sequences, series, and it was very different. So I went ahead and thought it'd be easier for your brains in studying to go ahead and do a test on the bigger portion and a quiz on the smaller portion. And the 75-25 made 100 points, chapter 9, right? Okay. Chapter 10. So that's why in your homework sheet, you guys should have been seeing it was called chapter 10A. You didn't notice? And the homeworks are 10-1, 10-2, 10-3, 10-4, 12-3. Then we come back, skip 10.5. That is our 12.3. Remember 10.5. That's more. Then we come back, do 10.6, 10.7. I think we're even skipping. I just did it, but it's okay. 10.6, 10.7 quiz, just like chapter 9. Does that make sense?
Yes.
75, 25, 100 points. Chapter 10. Huh? Chapter 12. Chapter 11 we're skipping. It's three-dimensional vectors. Physics people or possible physics people might want to actually look over it. But otherwise, we're okay. We've done some pre-physics. We'll stop in the two-dimensional. And we'll leave the three-dimensional, the thumb rule. Is that what it's called? Not the thumb rule. That's what I call it. The right-hand rule. Thank you. The thumb trick is for partial fractions. All right, you guys getting it down? My artistic ones. Basically, you could almost teach this class, and this section. My non-artistic ones. Hang in there. My non-artistic ones, hang in there. I will show you the non-artistic way. And maybe my in-between ones, you'll have a little more fun trying to do better than you would have originally if I hadn't shown you some tricks. What am I talking about? We have to take a two-dimensional conic and bring it into the third dimension by visualizing rotation. You can say revolution, you can say rotation. Anybody in wood shop? You can kind of be thinking of a lathe. Not in the sense of necessarily how a figure is formed on the lathe, but still somewhat the idea of what can result. What can result when we do something like spin a parabola. If we do something like spin a parabola. I did have a really cool illustration once, but a very over-eager student 2 years ago sadly broke it. It's kind of sad. Needed to be welded. It was then given to someone who has a welder, and I never got it back. Maybe he still has it, so if you're maybe in a class with someone who would have a welder on campus, you could ask him. But otherwise, I will try to help you visualize as best I can without said demonstration. And I think we can do it. You can ask nicely. Maybe it's somewhere. It'd be really nice if it was found because it was a really cool illustration. Ready? Quadric surface, snazzy name for a 3D analog. 3D, third dimension, three-dimensional analog of a conic section defined by quadratic equations in 3 variables. Thank goodness we will not be writing equations of these. We'll just be seeing and visualizing them. Taking the two-dimensional that we can work with from sections 10.1, 10.2, 10.3, 10.4, and then spinning them. And if I were to show you the homework, if we had time, you would be able to see that they're going to give you an equation that you'll have to do the 10.1, 10.2, 10.3, 10.4 work of. I need to get a picture of it first, and then here's where this comes in. How do I take a conic and spin it? Well, paraboloid. What if we had a parabola? Try to put a parabola centered at 0, 0. Let me make it a little bit better. Try to put a parabola centered at 0, 0. Struggle. Okay. A paraboloid is formed whenever you take a two-dimensional parabola and spin him around his axis of symmetry. We show the spinning by showing a little curved arrow. You imagine that this is an actual, like 2 sticks with a parabola on it, and you spin, 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 and guess what you would form? Not a cone. Some sort of bowl-ish thing. Not Ebola. And if you want, you could form like a z-axis, and you could have some fun with it. This would be the solid. This would be the solid region. What would the surface be? Just the outside. It would be hollow. We're going to be playing with more three-dimensional stuff tomorrow. That came in for you, Joel. Thanks, bud. Great time? Oh, yeah, she is. She is. It's going to be awesome. Anybody else want broad shape bed? Feel free to grab it on your way out.
Yeah, dude, I'm so as far as
Why are they so nice?
as
start with the play?
Yeah.
I only have 2 more questions for the correction.
If you finish
So I'm
it,
gonna
feel
try to
free.
do it in 2.
Totally cool. I just wanted to, because I know Joe's been working hard too. And, yeah.
Is that what they made, like a parabola that they spun or whatever to make
Say it one more
the
time.
welding project thing? Okay. Is that what they made?
Well, no, they made, it was actually on this. They made the two-dimensional. And so they welded together like an X and a Y axis, and they had like a parabola on it. Actually, it had a hyperbola. And so when I spun it real fast, like you could see the bowl,
Oh,
which was really cool.
yeah, that's cool.
Yeah, it was really cool. Just that part broke in half at the middle point.